This video lecture is meant to cover the information found in Unit 11, Objective Number 6, which has to do with percent yield. It says you're calculating the theoretical yield, the actual yield, and the percent yield of a chemical reaction when given appropriate information. Well, percent yield is really just a very simple and straightforward percent problem, much like you would have a percent score on a test. So I'm not going to read this tutorial to you, but essentially the percent is given in as an equation as the amount you actually get divided by the amount you're supposed to get or theoretically can get, and then you multiply by 100. And so, you know, the analogy here is a test score, but there's lots of other applications of percentage in sports and other things. In chemistry, percent yield is trying to tell you that if you have a chemical reaction and you're supposed to get 100 grams of product, but you only end up making 80 grams of product, well, that's an 80% yield, right? And so here is the equation. The percent yield is equal to the actual yield divided by the theoretical yield. Now, the theoretical yield is the answers that you got when you did stoichiometry problems and you determined the grams of product. That's your theoretical yield. So this is the number you get from stoichiometry. From a stoichiometric problem. All right, so the theoretical yield is a number that you calculate on a piece of paper with a calculator and your pencil. The actual yield is the amount of product that you actually make at the lab bench. So this is what was made, or how much was made in the laboratory. And so typically, this information is harvested from a data table or is given to you in the word problem as the actual amount of substance that was produced. All right, so let's go ahead and we're going to go ahead and jump to the first problem set, which has some basic problems and ones where you will use stoichiometry. So it says, using stoichiometry, you calculate that you will get 300 grams of a product, but you actually only get 213 grams of the product. What is the percent yield? Okay, well, remember, percent yield is the actual divided by the theoretical, and then you multiply by 100. So here, percent is equal to, well, you calculate that you'll get 300 grams, so that's going to be your theoretical. You actually get 213 grams, so that's your actual. So this becomes 213.0 divided by 300.0 times 100, and our answer here, maintaining four significant figures as both of our measurements were, works out to 71%. The next problem says if the percent yield of a reaction is 75% and the theoretical yield of the product is 18 grams, what is the actual yield? So in this case, you're given the percent of 75%, and 75% is actually 75 divided by 100. So we take it out of its percent form and we put it into its fraction form, and that is equal to the actual divided by the theoretical. The actual is what we are trying to find, so that's our x. Our theoretical yield is 18 grams. So this problem, because we have, this is an equal sign, not a multiplication sign, this is a cross multiplication problem. So if you're not familiar with this technique, you multiply the denominator of one fraction times the numerator of the other fraction, and that's 100x. And then you do the same with the other side, and so this is 75 times 18, and then we need to divide both sides by 100 because we're trying to solve for x all by itself. And so in your calculator, your calculator work is 75 times 18 divided by 100, and because we had two measurements. We had 75% having two significant figures, 18.0 had three significant figures, so we need to round our final answer to only two sig figs. And so your answer should round to 14 grams. Number 3, if the percent yield of a reaction is 45% and the actual amount of product produced is 74.0 grams, how much product theoretically could have been produced? So we have a percentage, so that's 45 over 100. And that has to be equal to the actual divided by the theoretical. In this case, we are given the actual. So that's going to go in our numerator, 74.0, and our denominator is our x. Okay. Remember, this is cross multiplication. So 45x is equal to 74.0 times 100. Getting x all by itself, we have to divide both sides by 45. And so the math in your calculator, 74 times 100 divided by 45. And let's see, significant figures, I think we have to do 45% had two sig figs. This number here had three sig figs, so we have to round our final answer to be 160 grams. Okay, now we are down at problem number 4, and problem number 4 says if you start with 20 grams of lithium hydroxide and plenty of potassium chloride, how much lithium chloride could theoretically be made? Use stoichiometry. You know, a box problem. Well, a box problem is the chain conversion fractions that we have used, and so effectively this is your three-step problem. You're given grams of lithium hydroxide. That's this substance right here. You are asked to find how much lithium chloride could theoretically be made. So that's x grams right here. Now the fact here that it says plenty of potassium chloride, that's this substance right here, we're not given any numbers associated with this substance. And so all we're saying is that there's lots of potassium chloride and you will use up all 20 grams of lithium hydroxide. So the KCl and the KOH in this problem have nothing to do with the math that you're going to do. All right, well, doing our three-step problem, start with the quantity given, 20.0 grams of LiOH. Set up your first conversion fraction, which is grams of LiOH in the denominator, 1 mole of lithium hydroxide in the numerator. Looking up the molar mass for lithium hydroxide, we get 23.9. The second fraction will be moles of LiOH in the denominator and moles of LiCl in the numerator. And so from the balanced equation, which I believe this equation is, it's very straightforward, it's a 1-to-1 ratio. We have 1 to 1 to 1 to 1. Our third fraction is going to convert moles of lithium chloride into grams of lithium chloride. And so grams of lithium chloride from the periodic table is 42.4. All right, grams of lithium hydroxide will cancel. Moles of lithium hydroxide will cancel. And moles of lithium chloride will cancel. Our original number, 20.0, had three significant figures, so our final answer should have three significant figures. And so we get 35.5 grams of LiCl. This number right here, 35.5, represents our theoretical yield for this problem. Okay, stoichiometry gives you theoretical yield. So for part B, 4B, it says after doing the above experiment, the reaction produced only 6.0 grams of lithium chloride. What is the percent yield of the experiment? So the percent yield is going to be the actual yield of 6.0 grams divided by the theoretical yield of 35.5 grams, and then multiply that answer by 100. Now 6.0 has only 2 sig figs, so our final answer is going to only have 2 sig figs. And so when you enter this correctly into your calculator and round it, you get 75% yield. So at this point, pause the video, do problems 5 and 6, both parts A and B. When you're done with those problems, start the video and check your answers. Go ahead and pause the video now. All right, are you ready for an answer check? Here are the answers to numbers 5A and B, and number 6A and B. All right, I am going to now post the actual work for these problems, and if you need to study these answers for any length of time, go ahead and pause the video because I'm not going to leave the answers, the work done out for very long. So here are the answers done out for problems 5 and 6. Pause the video if you need help studying or understanding how these answers were arrived at. When you're done checking the answers in your work for numbers 5 and 6, go ahead and try number 7. Pause the video now to try number 7. So here are the answers and the work shown for problem number 7. All right, the next part of our percent yield lesson has to do with determining percent yield if you are given a data table. Right, so this is going to be the topic for a different video lecture. So for now, that's all I have, and I'll see you in the classroom.